Plandex, autonomous refactoring and release management for large code bases. Plandex is an open-source AI-powered coding assistant designed to handle large, real-world programming tasks that span many files. It uses modern language models, LLMs, to plan, apply, and verify multi-step changes. Unlike simple text-complete coding tools, Plandex builds a plan sandbox. It generates all proposed edits in a separate space, viewable via Plandex diff, and only applies them to your project when you explicitly confirm using Plandex apply. This plan then apply approach means you can rename functions, extract modules, or refactor code across dozens of files without leaving your repository in a broken state. For example, one tutorial notes that Plandex can migrate a function name across 40 files without half going to disk until all steps are correct. Under the hood, Plandex indexes large code bases using tree-sitter parsers. It can directly load up to 2 million tokens of code context, roughly 100K per file, and even handle 20 million tokens or more by building a fast project map. This means Plandex can query and update only the relevant parts of a large repo for each step. It also uses smart context caching across AI calls to reduce cost and latency. In practice, Plandex never sends your entire codebase to the model at once. Instead, you explicitly load the files or directories it needs. This keeps the LLM focused and avoids overwhelming it with irrelevant code. Plan execute workflow for multi-file changes. The core workflow with Plandex is create a new plan or REPL session. In your project directory, run Plandex new or just Plandex to start the REPL. It builds an interactive prompt or session tied to a plan. Load project context. Tell Plandex which files or folders are relevant, e.g. Plandex load src.py tests.py. This builds or updates the project map so the AI knows your code structure. Give the AI a task, prompt. Use Plandex tell your instructions to describe the refactoring or feature. For example, rename all public functions from camel case to snake case across src libx and tests, preserving deprecated aliases. The model will then propose changes. Review changes, diff. Plandex accumulates the suggested edits in a separate sandbox. You can inspect them with Plandex diff or Plandex diff file name to see a git-like diff. You can also view a step-by-step log, Plandex log, of each edit. If a particular step is wrong, you can roll back, e.g. Plandex rewind step, fixing only the problematic part while keeping earlier approved edits. Apply to working tree. Once satisfied, run Plandex apply to write all approved changes to your local files. Plandex's version control plan ensures you never partially break the code while ordering edits. Plandex uses its plan execute loop. It not only plans code edits, but also generates any needed shell commands, installing packages, running builds tests in a script, apply.test. For instance, after applying changes, it may run your test suite or build process. If an operation fails, Plandex can roll back and automatically debug the failure. It will feed the error output back to the model and try to generate fixes, iterating until success or a maximum number of tries. This means Plandex can catch simple errors or typos in real time, much like a pair programmer suggesting fixes. By default, Plandex is cautious about executing commands. It only runs commands you explicitly requested or are strictly necessary, e.g. running tests after a change. You control this with settings like Plandex set config can exec false to disable command execution completely, or by using different autonomy levels. At the safest level, Plandex will ask your permission before running any commands. This flexibility ensures you can iterate on the plan in a secure way, step by step, running tests locally and opening pull requests. Once Plandex has applied your changes locally, the next steps mirror a normal development workflow. Run tests, build locally. After Plandex apply, you should run your test suite, for example PyTest or npm test, to ensure everything passes. Because Plandex accumulated edits and allowed you to preview them, you should have fewer surprises. If tests still fail, you have two choices: fix the remaining issues manually, or use Plandex debug PyTest to let the AI try autofixes. In practice, many teams run the full suite after Plandex apply and may use the automatic debug as a convenience step. Commit your changes. With tests green locally, use git add and git commit. Plandex can even suggest a commit message when used with Plandex tell AC task, or you can write your own. The Linux command library notes that Plandex tell AC will apply and commit changes for you. Make sure everyone stays on a feature or refactor branch. Don't commit directly to main. Push and open a PR. Push your branch to your code hosting, GitHub, GitLab, etc., and open a pull request, PR. Many teams use tools like GitHub CLI, GHPR Create, or web interfaces. The PR is where peers can review the diff, just as with any code change. Because Plandex kept changes atomic and per step, the diff will be clear and easier to review. Automated CI tests should run on the PR. Merge and deploy. Once the PR is approved and all CI checks pass, merge it into your main/trunk branch. Now the changes are ready for release. For production deployment, use a typical staging dev prod pipeline. You might push to a staging environment first, via GitHub Actions or your CD tool, verify behavior, and then gradually release to production. By adopting this workflow, even developers new to AI coding tools can follow familiar Git practices. The crucial difference is that Plandex handled the multi-file refactor for you. You still review each change, run the usual tests, and use pull requests. In effect, Plandex offloads the heavy planning and editing work to the AI, but leaves final control, apply versus reject, to you. Staged rollouts and blast radius control. When deploying refactored code, it's wise to limit the blast radius of any potential issue. This often means using feature flags or canary releases. For example, if Plandex helped add a new feature or change behavior, you could hide it behind a toggle and enable it for a subset of users first. Industry best practices recommend rolling out new changes gradually. For instance, use a ring deployment. Deploy first to internal or staging users, then to a small percentage of real users, and only fully release once the feature proves stable. If you detect problems, test failures, error spikes, you can quickly roll back or switch off the feature, dramatically limiting the blast radius. As launch darkly notes, carefully staged releases limit the blast radius if something goes wrong during a rollout. In short, treat Plandex-generated changes just like any other code update. Deploy them behind flags or to a test segment before hitting 100% of users. Use monitoring and automated rollback rules if possible. This approach keeps you safe, even if the AI-introduced change has an unforeseen bug. Performance insights for complex refactors. Plandex is powerful, but handling large multi-file tasks can incur cost and latency due to LLM usage. Each step requires model calls. A reference tutorial notes that 50 files in one plan means many model calls. So you should monitor spend and perhaps split a huge refactor into smaller plans when possible. Context caching helps. Plandex remembers code it is already loaded, so it doesn't resend the same content needlessly. Still, every time Plandex needs to reason about code, it uses tokens, which may have an API cost, and time to wait for the LLM reply. In practice, a single Plandex session might take seconds per LLM call. Complex plans with many iterations or debug loops could take minutes to complete. To manage this, monitor token usage and time. If a plan is slow or expensive, consider breaking it into parts. For repetitive edits, like renaming dozens of similar functions, one might reuse a cheaper open-source model, e.g. CodeLlama, on parts of the code. Use local models if privacy or cost is a concern. Plandex works with local deployments of open-source LLMs. This avoids network latency and token fees. It also addresses sensitive code scenarios. See next section. Enable caching and pack multiple steps logically. Plandex automatically caches context for OpenAI, Anthropic, Google calls. You should still provide only the necessary files in Plandex load, so as not to waste context on irrelevant code. For error correction, Plandex's iterative debug feature is notable. If tests or builds fail, Plandex can rerun the command up to several times, each time sending the error logs back to the AI and tentatively applying suggested fixes. In many cases, this can automatically fix typos or syntax issues without manual intervention. Of course, non-trivial errors may require a human step, but this built-in loop often saves time debugging. Security and governance best practices. When using Plandex or any AI agent in a codebase, follow standard DevOps safety practices. Credentials and secrets. Never hardcode secrets. Plandex can load context into an external LLM, so you should avoid placing any API keys, passwords, or private URLs in your code or prompts. Instead, use environment variables or secret management tools, e.g. encrypted vaults, GitHub secrets, and keep them out of the code. GitHub's best practices likewise emphasize never committing secrets and applying the principle of least privilege to any keys. If your project is highly sensitive, consider hosting Plandex on a secured internal system and using only local models, so no data ever leaves your network. Auditability and version control. All Plandex changes are version controlled before they hit your repo. Each plan has its own history log, Plandex log, and all diffs can be reviewed before application. This provides a clear audit trail. You can see exactly what edits the AI proposed and when, and who applied them. If your organization needs an extra layer of traceability, require that every Plandex change be approved via a code review in a PR, where CI ensures tests pass on every step. The fact that Plandex suggests commit messages and can even branch plans for experimentation also means every idea is systematically recorded. Least privilege and safe modes. Limit Plandex's privileges the same way you would any automated tool. For example, do Plandex work on a non-production branch? In Plandex itself, you can disable automatic execution of commands, set config, can exec false, or turn off full auto apply modes. As the docs warn, features like full auto mode can make many changes without prompting, so only use them when you're ready. In normal use, review each diff before applying. Also ensure your Git environment is clean, no uncommitted changes, before running Plandex, so you can easily revert if needed. Blast radius controls. As discussed above, use feature flags and incremental deployment to contain any bad effects. If Plandex changes multiple microservices or repos, deploy step-by-step and monitor each service. The slogan from Feature Flag Best Practices applies here. Start small and stop the rollout if metrics or tests fail. Conclusion: Plandex brings AI planning and code generation to large-scale refactoring and release management. It shines when you need to make broad changes across many files or services, saving the effort of writing repetitive edits by hand. Developers, even those new to AI tools, can use Plandex by following a familiar workflow. Create a plan, guide the AI, inspect the diff, apply changes, run tests, and then use standard Git PR practices to merge and deploy. This approach is particularly useful for consultants, large team projects, or legacy codebases, where changes must be safe, reviewed, and auditable. To get started, one practical next step is to install Plandex and try it on a small feature or refactoring in a test repo. For example, follow a tutorial scenario, clone a sample project, run Plandex, load a couple of files, and ask the AI to make a change, like renaming a function or adding tests. Plandex's interactive prompts will guide you through, and you'll see the sandboxed edits and log of steps. This hands-on experiment will help you trust the tool's behavior and see how it fits into your normal coding process. From there, gradually incorporate it into real work. Always start on a separate branch, protect secrets, and monitor costs. In the long term, Plandex's blend of full autonomy or fine-grained control makes it suitable for both AI-curious beginners and seasoned DevOps teams. With careful use of the plan execute loops, context indexing, and safe rollout practices described above, your team can leverage AI to manage even the most complex refactors and releases with confidence. All links to sources are available in the text version of this article. You can find the full article at easycoding.tools.blog. Thanks for listening. For more practical AI coding guides, tool comparisons, and resources for builders, visit easycoding.tools. And if it's easier to remember, just go to aibuilds.it. It redirects to easycoding.tools.